This is Mr. Alexander, and I want to talk to you about imaginary and complex numbers. Imaginary numbers are the result of taking the square root of a negative number. So your real numbers are like 1, 2.2, -7. Those are the real numbers. Imaginary numbers they're in a different number set, and they occur when you take the square root of a negative number. For instance, -49, the square root of that, is simply the square root of 49 times -1. So you can break that into two square roots. That's the square root of 49 times the square root of -1. Well, the square root of 49 is simply 7, and the square root of -1 is I. So the square root of -49 is 7i. And here, the square root of -8, well, that's simply the square root of 4 times -1 times 2. So I can break that into three square roots. I can say square root of 4 times the square root of -1 times square root of 2. Well, the square root of 4 is 2. The square root of -1 is I. And then, of course, square root of 2 is just square root of 2. So the square root of -8 is 2i root 2. Now, the square root of -144 is the square root of 144 times -1. I can break that into two square roots. 144 times square root of -1. Well, the square root of 144 is 12, and the square root of -1 is I. So these imaginary numbers, there's only actually 4 of them. And this is the imaginary number set. This is all 4 of them. I equals the square root of -1, that's what we were just talking about. I squared equals -1. I cubed equals -I. And then I to the 4th power is the real number 1. So these are the only 4 numbers you need to know in the imaginary number set. I'll refer to these again in a moment. First, I want to do some addition and subtraction. So 2 plus I plus 6 plus 3i. We're going to combine like terms. So I'm going to do -2 plus 6. That's the real component, plus I plus 3i. That's the imaginary component. So real numbers go with real numbers, imaginary numbers go with imaginary numbers. So -2 plus 6 is just 4, and I plus 3i is 4 i's. Now, when you've got a number that has a real component and an imaginary component, these are called complex numbers because it has a real number and an imaginary number. Over here with subtraction, it's the same thing. We're still going to combine like terms. So we've got 4 minus a -6. So 4 minus a -6. And I'm just going to change that, since I'm going to distribute the minus sign, I'm going to just change this to plus right here. And then I've got -2i minus 4i. Combining like terms. Okay, so 4 minus -6 is 4 plus 6. That's going to equal 10. That's my real number. And then I've got -2i minus 4i. That's -6i. So that's my complex number because it has a real component and an imaginary component. 10 minus 6i. Okay, well, that's addition and subtraction. So the next thing we ought to talk about is multiplication of complex numbers. So this complex number times this complex number. And here we're going to do something called foiling. FOIL stands for first, outers, inners, last. That's the way we're going to multiply. So I'm going to do 2i times 4i, which is 2 times 4 is 8i squared. first outers is 2i times negative 8, so that's negative 16i. First outers inners is 6 times 4i, which is positive 24i. First outers inners lasts. 6 times negative 8 is negative 48. So now I need to combine like terms. But first, 8i squared. Remember back up here when I said there's 4 numbers you need to know? I squared equals negative 1. So if I change that to a negative 1, that's going to be 8 times negative 1. I can combine these like terms. Negative 16i plus 24i is plus 8i. And I've got a negative 48. This 8 times negative 1, that's just negative 8. So I should combine that with this negative 48. So negative 8 minus 48 is negative 56, and I still have that plus 8i. So when you multiply two complex numbers together, it's going to result in another complex number. What about this one? This 1 minus 4i squared. Well, that's the same as saying 1 minus 4i times 1 minus 4i. So I'm going to FOIL it out again. FOIL. And this time, firsts are 1 times 1. This is just 1. Outers, 1 times negative 4i is negative 4i. Inners, negative 4i times 1 is still negative 4i. And lasts, negative 4i times negative 4i is positive 16i squared. Now I'm going to combine like terms, so I've got a 1, I've got a negative 8i, negative 4 is negative 8i, and then 16i squared, well that's just minus 16, because remember I squared equals negative 1, so I just put the negative there. 1 minus 16, it's negative 15 minus 8i. That's how you multiply complex numbers. The last thing I want to show you in this video is how to simplify i's with exponents. So remember up here I told you there's only 4 numbers in the imaginary number set. Well, we're going to use that property to simplify I to the 15th. And the way I like to think about it, maybe your teacher thinks about it differently than me, but the way I think about it is I try to think of a multiple of 4 that's close to 15 without going over. And in this case, that's I to the 12th. But I want to keep this equal to 15, so that's going to be 12 plus 3 is 15. And the reason I'm going to do that is I'm going to break this into 2 exponents. So I'm going to say that's I to the 12th times I to the 3rd. Because addition up in the exponent is the same as multiplication in the base. So I just took that plus sign up in the exponent and turned it into multiplication down here in the base. And the reason I did that is I know that 12 is 4 times 3, so I can say that's I to the 4th to the 3rd power. Now here, this is still I to the 3rd. Well, I to the 4th, why did I do that? Well, the reason I did that is because up here, I to the 4th equals 1. So I'm going to replace that I to the 4th with a 1 to the 3rd power. And I to the 3rd equals negative I. Negative I. So I've got 1 to the 3rd, that's 1 times 1 times 1, that's still 1, times negative I. Well, anything times 1 is just itself. So the answer here is negative I. So I to the 15th is negative I. What about 26? So I'm thinking of multiples of 4 that are close to 26, but without going over. So I'm thinking 24. So that's I to the 24th plus 2. And I'm going to break that into 2 i's, I to the 24th times I squared. Now 24 is just I to the 4th raised to the 6th power. 4 times 6 is 24. Now here I still got that I squared. Well, I already told you that I to the fourth is 1, and it's still 1. So this is 1 to the 6th power times I squared. I squared is negative 1. Well, negative 1 to the 6th power, that's 1 times 1 times 1 times 1 times 1 times 1. It's just 1. 1 times negative 1, the answer here is negative 1. Same process here, 41. Multiple of 4 that's close to 41 is 40. So I'm going to say that's I to the 40th plus 1. I'm going to rewrite it as I to the 40th times I to the 1st power. Well, 40 is just I to the 4th times 10, or to the 10th power, sorry, times I. I to the 4th is 1, so this is 1 to the 10th power times I. Well, 1 times I is just I. So that's my answer there, I. And last one, 80. Now 80 is a multiple of 4. So here, that's just 4 times 20, isn't it? So I'm going to rewrite that as I to the 4th times 20 to the 20th power there. So that's simply 1 to the 20th power, which is simply 1. That's how I like to think about those I problems. And that's all I wanted to show you with imaginary numbers and complex numbers, addition, subtraction, and multiplication. I hope this was helpful. Thanks for watching.